This is going to be a video on 7.1, which is the dilation transformation. A little bit of a different transformation than the others, as you'll see here. But let's go ahead and get to it. Do a mic check here real quick, just to make sure that yeah, okay. So, um, the last type of transformation, like we said here, is the dilation. And the dilation is a little bit different than the other ones. The other transformations, which were reflection, rotation, and translation, were isometric transformations, which means they preserve the congruency and the distance between the points. Dilation is not isometric, which means, metric, probably misspelled that, so I'm sorry about that, but it's not isometric, which means that it does not preserve the segment's distance. Like before, if I have, this distance was 5, if I translate, rotate, or reflect that, that distance is always going to be 5. If I dilate that, that distance will not always be 5. So mainly it's dealing with the distance between points, right? The dilation does not preserve the distance between 2 points, or the same distance, I should say. Dilation does require a scale factor, which should sound familiar because we used a scale factor a lot when we did similarity stuff, which is what a dilation is. A dilation is a similarity type of move. And this is usually represented by the variable k. If you use a different variable, it's fine. It's just that we usually use k when representing the scale factor in a dilation. And they also require a center of dilation. So center of dilation. That's kind of like the center of rotation. It's kind of like the line of reflection. It's basically the home base for what reference you're dilating at. So, if I have an object here and I'm dilating it from this point, that means that, if I'm enlarging it, that means that I'm going this way and I'm making a bigger triangle over here. So then the big triangle is over here. Whereas if I'm dilating it, say, from this point right here, that means I'm making a bigger triangle, but maybe not as big, and in over this direction right here. So it's kind of like, what direction are you dilating it from? Where is everything expanding out from? Now, from us, we're going to mostly use 0, 0, which is the origin, but we will briefly cover how to do it with other centers rather than just the origin. But we're going to start with just assuming that the center is always at the origin. So there's two types of dilations we have. We have enlargements, which occurs when the scale factor is more than 1. And then we have reductions when the scale factor is less than 1. The scale factor will not usually be negative. So it's usually going to be, 1 point something or 0 point something. Luckily, both are handled the same way. We simply multiply the x and y by the scale factor. So if you're dilating by a factor of k, that means you're going to do k times x and k times y. That's it. It's one of the easier dilation, or one of the easier transformations to do, because it's just one rule for all types. So let's just do a quick practice here. If we want to dilate these by a scale factor of 2.5, I'm simply going to take each point and multiply it by 2.5. Both the x and the y, I'm going to do it the same for all points. No difference between them. So this right here, this would be negative 5, 4 times 2.5, which is going to be 10. And then over here, we have positive 5, and then 2.5 times negative 5 would give me negative 12.5. And then here we have 10, and then 2.5 times 3 is going to be negative 7.5. And then over here we have negative 10, and then 7 times 2.5 is going to be 17.5. So those would be our new points. Right? Again, all it is just straight multiplication all the way through. Same thing if it's less than 1. So this is an enlargement right here. This is an enlargement because the scale factor is more than 1. This is a reduction because the scale factor is less than 1. So we're going to simply multiply everything by 0.4 times 0.4 times 0.4 times 0.4 times 0.4. Right? So 5 times 0.4 is going to give me 2. 6 times 0.4 is going to give me 2.4. 9 times 0.4, whoops, is going to give me 3.6. And then 4 times 0.4 is going to give me 1.6. Over here, we're going to have 1.2 and negative 0.8. And then for our last point here, we're going to have, oops, there we go. We're going to have 12 times 0.4, which is going to give me 4.8. And then 8 times 0.4, which will give me 3.2. So those would be my new points. So again, all it is, straight multiplication all the way through. Just look at what your k is and multiply it to all the points. Make sure you're careful with your signage, so make sure you preserve the negative signs and all that. But other than that, it's just straight multiplication. Now, if you do have a center that's not at the origin, you have to do that little extra step here. So this is almost the exact same thing we did with rotations that weren't about the origin. If you want to dilate something that's not at the origin, what you have to do is translate it to the origin, dilate it, and then translate it back. So here's what I mean. We want to dilate this point by a factor of 2 from this center. So what I do is I take my point 4, 8. I'm going to basically shift it to my new center. I'm going to do that by doing the opposite of what these values are here. So this is 3 and negative 1, positive and negative. So I'm going to do minus 3 and add 1. I'm going to do the opposite of what they are here. This will allow me to kind of reset everything to be like if it was 0, 0. So I'm basically zeroing out this point. Remember, when I do my dilating stuff, I usually want it at the center, right? I want it at 0, 0. I want it at the origin. Well, I'm not at 0, 0. I'm at 3, negative 1. So I'm going to undo this by subtracting 3 and adding 1. So I'm basically going to kind of like zero this out, but I'm going to apply it to this point here. So this would be 1, 9. And then I'm going to take that 1, 9 and dilate it by normal. So times 2 to both of them. Get 2, 18. So this part here is just the normal dilation that you just did last time. And then you're going to take that point and you're going to undo what you did. So here I subtracted 3 and added 1, so I'm going to add 3 and subtract 1. Here I'm going to do I'm going to undo what I did in the first step. I'm going to get 5, 17. And that will be my new dilated point. That will be my final answer. So all that happens is that if you're changing your center, you simply take the points you have, you apply them in reverse to your point that you want to dilate, you do your normal dilation, and then you apply them as they were to your newly dilated point to get your final answer. So you're going to use these numbers twice, once in reverse to kind of undo them, and then once like normal to reset them essentially. It's the exact same thing we do with rotations that don't have a center at the origin. A little bit more complicated, but it's just 2 extra steps, adding and subtracting. So let's just kind of round this all up here to make sure we know all 4 types of transformations. So we have 4 types of transformations we should know. Reflections, which is a multiplication one, right? If you want to reflect over the x, you're going to multiply the y coordinate by negative 1, the opposite, right? If you reflect over the y, you're going to multiply the x coordinate by negative 1. Again, think opposites. And if you're reflecting over the main diagonal, you simply swap the x and the y. You don't multiply by negative 1, you just swap the x and the y values. Those are our 3 reflections. For a translation, if you're going to translate by a vector of m, n, so I didn't put any numbers here, I'm just going to keep it general for right now. All you do is you take your x coordinate and you add it to the x coordinate of your vector. Take your y coordinate and you add it to the y coordinate of your vector. Technically, you can do minus as well. Like if this was like a negative 5, it'd be y minus 5, or you can write it as y plus negative 5, either way. So I usually just write the plus sign there, but if you want to do plus minus, you can as well. But also all you do for a translation is you take these values here, positive or negative, and you add them into the original x and y. Rotations are probably the hardest ones because they have 3 different rules. If you're going 90 degrees clockwise, or remember, this also works for 270 counterclockwise. Remember, you can do either 90 degrees clockwise or 270 degrees counterclockwise. It's the same transformation. This will end up being y comma negative x. Remember, you multiply the x by negative 1, and then you swap the values when you're doing clockwise rotation. If you're doing 90 degrees counterclockwise or 270 clockwise, because remember, this works for both, you're going to multiply your y coordinate by negative 1 and then swap them. So it would be negative y comma x. Again, very similar transformations, but just different variable that you're multiplying by negative 1. And then for 180, all you do is you multiply both of them by negative 1. You don't swap, you just multiply both by negative 1, and you get negative x comma negative y. Right? No swapping for the 180 degree rotation. And 180 can be done both counterclockwise or clockwise. It doesn't matter. It's going to end up the same result. And then dilating we just did. If you're going to dilate, you multiply both coordinates by whatever you're dilating by, your scale factor k, and then you're done. So those are the 4 transformations for this section. Make sure you can do all 4. Again, for rotations and dilations, those have different centers other than the origins sometimes. So normally, your centers here will be at 0, 0. But if I do give you a different point other than the center at 0, 0, then you should know how to do that. And that is, like I said, what we just did right here. You undo your new center, you apply the correct dilation or rotation, and then you redo your new center, right? So that's probably the trickiest problems that we're going to have in this chapter. So just make sure that you have those down. If you don't, let me know, and I'll be glad to help you out, okay? So that's it for this video. Hopefully you enjoyed it, hopefully helped you out, and have a good day.